Time for composition of functions or composite functions. We've talked about operations on functions, so let's just kind of remind ourselves on those a little bit. You could have, for example, f of x minus g of x, f of x plus g of x, f of x times g of x, and f of x divided by g of x. Now we're going to look at a whole other idea where we're embedding one function inside of another. So now we're going to switch gears and do something that looks a little bit more like this. F of x of g of x. This little of sign, that tiny little o, means that we're going to put one function inside of another. So this is going to really look like f of g of x. So you can see how we've kind of embedded g of x inside f of x. So let's look at an example. Let's say that we have f of x equals x minus 4, and let's do a different color. G of x equals 2x, and we are asked to find f of g of x. Now, this is a very common notation, f of g of x, but I prefer to write them kind of like ripples in a pond. So I'm going to rewrite this as f of g of x. Means the exact same thing. I think it's a little bit easier to see because when we work with these composite functions, we work from the inside out. So we're going to start with this g of x right here. So we're going to say that we have f of, and then we'll put in what g of x is worth, which is 2x. So we're just replacing g of x with what it's worth. Now that we have f of 2x, we're going to replace the x in f of x with the 2x. So instead of x, we have a 2x. So if f of x right here is really x minus 4, remember we're replacing x with the 2x. So f of 2x is 2x minus 4. So our f of g of x is 2x minus 4. These can kind of take a minute to get the hang of. So let's do another one or two of these. Let's say that we have f of n equals 4n plus 1, and g of n equals 3n minus 2. And let's find g of f of n. So remember, I'm going to take g of f of n and rewrite it in that kind of ripple effect format. So we have g of f of n. So let's start from the inside out. And let's replace f of n with what it's worth, which is 4n plus 1. So 4n plus 1. So we're looking now for g of 4n plus 1. So all we're saying is that instead of n in g of n, we're going to replace n with 4n plus 1. So if we look at g of n, we know that that's 3 times n minus 2. And the n that we're using, remember, is this 4n plus 1. So 4n plus 1 replaces the n in g of n. So we've got distributive property here. 3 times 4n is 12n. 3 times positive 1 is a positive 3. And we'll bring down the negative 2. Combine like terms. And we have 12n plus 1 equals g of f of n. Kind of cool, right? Okay. Then let's plug in now a number. Instead of just having the g of f of n, let's plug in a number for n. Okay? So, starting with, let's say h of x equals a negative 3x plus 1. And g of x equals 2x plus 1. And let's find g of h of negative 3. So this one's already written in that kind of ripple effect format. So I'm just going to start out with h of negative 3. So I'm going to take our h of x value and replace x with a negative 3. So we have negative 3 of x plus 1, and the negative 3 is also our n value right there. So that gives us g of h of negative 3. So let's go ahead and work what's inside those parentheses there. Negative 3 times negative 3 is a positive 9. We'll bring down the plus 1. So we have g of 9 plus 1, which